time I saw so many people in the seat, and it would make me a little bit nervous. But I think it's really a good opportunity as here to borrow the thunder of Vitalik so that we can promote some of the research we're doing here in NTU. Today I'm going to talk about more on this security aspect of Web3. So I'm currently wearing two hats. One is I'm a faculty member of School of Computer Science and Engineering in the NTU. Another hat is I'm the co-founder of MetaTrust Labs, which is a spin-off from the university focusing on the Web3 security. So hopefully I will not do too much to merge today the talk and at least the half part. To everyone, this has been the amount of money stolen in the Web3 to August this year. I don't think this number is very accurate because there are a lot of hacking events or accidents are actually not fully reviewed. I think this is actually a very conservative number. And this is also bring the question, right? Since in the blockchain of the Web3 era, everything is assets, which means a lot of money, and security is still really important. But why this thing is still happening? Probably you can see from the newspaper, from different kind of channels, the hacking events is not, if not happening every day, at least 1 week, you can see some news, right? But now the question is that since the blockchain security is so important, what is the reason? Why don't we make it secure? Maybe this is some of the potential answer to this question. In the last couple months, we are trying to summarize all the possible attack surfaces of smart contracts. And you can see this is a huge map. Starting from the layer 1, the public chain, and now we have the cross chain, now the layer 2, we have the long-term ZK, all these things. All these foundations, they have the vulnerabilities problem. But on top of this smart, the layer 1, layer 2, you have smart contract, and then you have layer 3, the application, DeFi, GameFi, and so on, right? And each of these layers have their own problems, right? If imagine you are a developer and you are writing some Web3 blockchain applications, even I ask you to remember all the vulnerability names, it is tall order, right? Rather, you think you can try, when you write the code, you can avoid everything. And furthermore, beyond this existing code you're writing, actually there are other more challenging problems. For example, we have the software supply chain issues, which means when you're writing software nowadays, you are not building everything from scratch. Very likely, 90% of the time, whatever application you're writing, 60% to 90% of the code are actually borrowed from the open source ecosystem. And this is also very true for smart contract. We just did a very interesting study. We did the analysis. We found 80% of the smart contract, the code in the smart contract, actually from open source. Which means even you have done all this, your job, you invite some security auditing company to do the software auditing, but all the third-party code, this 80% of third-party code, may not be fully checked and audited. And this brings another problem. And some of our research papers published in the last couple of years found that this kind of open source related kind of agreement vulnerability is not only happening in the layer 1, layer 2, but also happening in the smart contract itself. So imagine with all of these challenges, how can you secure your application? I think this is the things we want to address. And this is exactly the gap between the security authority and the software development team. Because now the software developers want to go for this agile development. They want to release their software every week, every 2 weeks. But you cannot, or you are not able to afford security auditing tasks every 2 weeks, right? So there is a huge gap between the security auditing team and the development team. So the goal for us, all the research we're really working on is how to bridge the gap to bring more automated solutions and bring more intelligence. Right? So this is, I think, the key things we want to highlight here. And within this industry, there are already very mature solution product called the DevSecOps solution, or DevSec 2 chains, the SAST to find vulnerability in your own code,
SA is finding the open source component in your software and review the NA vulnerabilities. And there are IST, DST to a different way to find vulnerability. So these are the very mature tools. So I will not dive into this, but rather want to, this is the commercial slide, right? We want to, this is the things MetaTrust is trying to do. Essentially, we are doing a DevSecOps to provide automatic vulnerability detection tools, not only in the development process, but also in the operation process, so that you don't really need to worry about security. Because you cannot just rely on auditing. When you put the chain online, the token online, you also need to monitor the security transaction. So the things we're doing is trying to starting from the software design and to the development testing, all the way to the operation. So we provide a full-fledged automated solution and give you the full 24/7 security support. Right? So this is the things we're doing here. One small thing I want to highlight here is for the design verification. I remember just now there's a question asked about the ZK kind of security, which seems a little bit more challenging. Not many kind of security auditing can easily audit their kind of circuit. So actually we have been working on the verification for the last 15 years, and we have recently just launched a very, I think, powerful verification platform for the first time, and we are able to verify a very complicated system. And we just verified the Uniswap version 3 in a complete manner. Right? So this is kind of things we are doing on the risk side, but we hope also to make this available for the kind of critical infrastructure of Web3. Now back to the business. So the title of this talk is talk about security copilot, right? We are talking about how the AI or AIGC can potentially help the security, especially on the Web3 security. So this is really the focus. So this is what the earlier work we published in the 2019 when we tried to first thinking about how we can use AI to find vulnerabilities. And the idea is actually very simple, right? Think about how you can apply AI in any domain. The simple idea is I have some training data, I train an AI model, and then I can use the model to do prediction, to have a certain kind of intelligence. So this is exactly the same idea. But here, what we are doing is slightly differently. Is that when we talk about the AI, all the research started or rooted from the NLP space. People treat everything as text. So this work actually is a very interesting attempt. We try to treat the code in a different way. Within code, software has its own structures and syntax and semantics. So if you want to learn something from the software, you should not treat the software as text. We should use the structured information in the software itself, so that the deep learning or the machine learning method can learn a more accurate behavior of the software. So this is essentially the things we did in 2019. The paper is published in a very good place, but the sad result is that when we are really trying to deploy this in the real application, we found that it's not a good result. The main reason for this is that the data set or the vulnerability typically is small. We cannot have millions or tens of millions like ImageNet. It's a huge database. We have maximally 200,000 vulnerability database, and that's actually considered as a small data set. The second thing is you have many unsynced vulnerability code before. For this kind of unsynced code, when you have a small data set, it's very difficult to achieve good results. Right? So this was the kind of the challenge we face. But this year, the ChatGPT go viral, right? Everybody is talking about ChatGPT, and there are a lot of, when it launched, there are a lot of interesting articles talking about, okay, how you can potentially leverage ChatGPT. You send your smart contract to the ChatGPT, and ChatGPT will tell you, okay, it has vulnerability or not, right? So this was some kind of very interesting news during that time. But when we saw this, we think, okay, this sounds very, very interesting, but whether the ChatGPT itself can really address the problem. So that's what the question. Interestingly, 2 weeks later, after the news released about using ChatGPT to do the audit, all the auditing firms started to panic. They started to publish articles to say, hey, ChatGPT is not going to work. Why? Because ChatGPT is a probability-based model. It cannot recognize the subtle difference in the code. I can easily change one character in a piece of code to turn a vulnerable function into a non-vulnerable function. But I don't think ChatGPT is able to have able to distinguish such kind of subtle difference in the one character chain. So they have showed many cases, there are false positive, false negative by ChatGPT in terms of vulnerability detection. So when we saw these two news, we are really thinking, okay, so what is really the right way of whether we have the potential application of the AIGC in vulnerability detection for smart contract. So this was really the question bothering us. And after a while, we figured out, okay, so since that direct using ChatGPT may not be a good thing, but maybe we can go from a slightly different angle. We were thinking, okay, what is the good things ChatGPT about? There are a number of capabilities in it. One of them is that it can understand and comprehend the code. So this is the part we start to think, okay, maybe we should not use ChatGPT to tell us whether it has vulnerability or not, but whether we could ask the ChatGPT to say, can you help me to understand what this smart contract is doing about? What are important and security-related operators, variables that I need to pay attention? And this is, you think about this is essentially the security expert or security auditor, what they are doing when they are doing security auditing, right? They are trying to figure out the important variables to say, hey, this is DeFi, there are interesting variable of doing transactions, maybe potentially can be manipulated by the attackers through our input parameter. So these are the things we try to ask ChatGPT to do. Once we identify the important piece, then we say, okay, please tell me how to exercise, formally, rigorously exercise doing all this program analysis formal method to find all the possible security paths and see which path can really lead you to vulnerability. So this is actually, we are trying to use ChatGPT as a kind of a method to, this is the recent paper we just submitted. This is the process, right? We are combining the capability of ChatGPT with the program analysis capability so that we can try to simulate how the auditor really understand how to detect vulnerabilities. And the result is pretty encouraging because after we've done quite some of intensive experiments, the false positive rate and false negative rate is below 20%, which is a much better result than any security scanning tools out there. Right? So this is the things where we have. So this is to find the vulnerabilities using static program analysis. And another thing we're trying to do here is to leverage a different method. When we run the code, how can we find vulnerabilities within the smart contract? So in this regard, the problem or the challenge is not to run smart contract, but rather the challenge is to really how to write a driver to test the smart contract. Because Google has a very famous project called the OSS Fast. The OSS Fast is a very important project trying to find the vulnerabilities in the open source libraries. So they have this platform. Everyone can contribute to this platform in terms of finding drivers to fast the open source library. But and they can find vulnerability. But the challenge is really the bottleneck is really the number of drivers contributed by the ecosystem. So given this, we are thinking, okay, how can we use the AIGC or the ChatGPT to help here? And the idea is that here we are trying to explore a different capability. In the first one, we are trying to leverage the code, the capability of code comprehension in the ChatGPT. But in this one, we are trying to leverage the capability of code generation of ChatGPT. And the idea is that when I give you a library I want to fast, or smart contract I want to fast, I ask the ChatGPT to understand, okay, what is the behavior, what is the documentation of the smart contract, and then ask ChatGPT to write the test driver based on the interface, based on the documentation. And in this way, we can simplify the filing process and make it in a more automatic way. Right? So that is why currently we are building more, we call it on-chip filing. We are using ChatGPT to generate driver, but at the same time, we are using many interesting on-chip data to make the filing more effective. So this is the second idea how to use the ChatGPT in the security analysis.